Gradle Enterprise's test distribution feature is a sophisticated way to run tests in parallel, making the most of your infrastructure and making the most of your time. In this video, we'll take a look at three approaches to making the test cycle faster. We'll look at running tests in parallel, running them across multiple machines, and finally, using Gradle Enterprise to run them with intelligent parallelism based on historical data for the fastest performance possible. Testing, as we all know, is a crucial part of the software development process. As we talk about aspects of build performance, we'll use this diagram. We have our source code and the libraries we need to compile it into binary artifacts. We also have test cases that tell us if our code worked. The log tells us what happened during the build and test cycle. In the build phase, we use the source code and libraries to create binary artifacts. In the test phase, we take those artifacts and libraries with our test cases to see if everything works. In a typical build and test cycle, testing can take 90% or more of the total time. And Gradle Enterprise's test distribution feature can reduce your total build time by as much as 90%. That's great, but why is testing so slow in the first place? There are several reasons. First of all, some tests need expensive objects like databases, web servers, directories, and virtual servers before they can run. Other tests may need remote services, and that means we have to deal with network latency. The sheer number of tests is also a factor. Proponents of test driven development say that for every line of code you write, you should have at least 5 lines of test code. But doing things in parallel is crucial. If we're running tests sequentially, the length of the test cycle is the length of all of the tests added together. That's unacceptable. We'll take a look at running tests in parallel in just a minute. So, we're all agreed we want to make the build and test cycle faster. Time is money, after all, and anything that saves us time is a win. But there's more to faster builds than just saving time. One benefit is that when builds are faster, people do more of them. More builds means smaller change sets and easier root cause analysis when something goes wrong. Another thing to keep in mind is your focus. When you run a build, your mind is focused on the code you're writing. The longer you have to wait for the build to finish, all the good ideas you had in your head may start to fade as the build goes on and on and on. The longer the build goes on, the more your mind can wander. Faster builds keep you in the zone and make you way more productive. So let's look at some ways to make testing faster. First of all, we can make sure we're using parallelism as much as possible. That will reduce the time significantly. Both Maven and Gradle spin up new JVMs to run test cases simultaneously, and some test frameworks, Jupyter and Spock, for example, start threads within the JVM to run tests in parallel. That's an obvious approach, but it has some problems. The first is figuring out how to distribute the tests among the different agents. To do that effectively, we have to know how long each test is likely to take. Here, we'll just do parallelism by assigning tests A, B, C, and D in order to the 4 threads, and we'll do the same with tests E, F, G, and H. That makes things faster, but it's what we call simplistic parallelism. A more intelligent approach would be to give each agent a similar workload, making the total test time as fast as possible. Secondly, if all of those parallel tests are running on your machine, you and your machine may not be able to do anything else. The biggest problem, of course, is that you're limited to the resources of a single machine. Another approach we can try is called CI fanout. CI fanout creates multiple CI jobs per build, with each job running on a different agent. That gets us past the single machine issue, but we still have problems. First of all, it's up to us to figure out how to balance the load evenly. Even worse, we're running the build process on every agent. Each agent is assigned some tests, but it has to run the build before it can run the tests. That's extremely inefficient. When all of those agents are finished, we can either leave all of the build logs and test reports on separate machines or come up with some way to put them together. Finally, CI fanout only works for CI builds. If you're doing a local build, you're out of luck. And because submitting changes to do a CI build has much more overhead than running a local build, you'll get feedback far less often. There's a way around all of these problems, and of course, that way is Gradle Enterprise Test Distribution. To start, test distribution uses historical build data to determine how to distribute the tests and give every agent a similar workload. Here, we're looking at how long each test typically takes. The insight from the historical data gives us intelligent parallelism. Even better, the data test distribution uses is constantly updated. If the amount of time a test takes starts to grow or shrink, test distribution automatically responds to that. And while tests are running, if a new agent becomes available, test distribution automatically uses that agent to make things even faster. Unlike CI fanout, with test distribution, the code is only built once. When everything is built, Gradle Enterprise gives all the agents a list of the files they'll need to run the tests. Some agents may have some of the files already, so the only files sent to the agents are new files they don't have. When a test finishes, the log for that test is sent back to test distribution. If there are any tests left, test distribution sends one to the agent. That continues until all the tests are done. As the last step, the agent sends other test outputs like Jacoco coverage data, so those are all in one place as well. Test distribution works for local builds, not just CI or merge builds. Finally, test distribution can also be used to run multiple test tasks at the same time. That means you can make the most of your time and your hardware every time you run a build. So let's look at this awesomeness in action. To keep things simple, we're going to start the build from the command line, but test distribution works however you kick off a Maven or Gradle build. Before we start, though, here's the test distribution panel in Gradle Enterprise. The agent pool we're going to use is called Demo Pool, and it has a minimum of one agent and a maximum of 10. Test distribution automatically scales the number of agents up and down. Notice that our agent pools have certain characteristics. The agents in the demo pool are running Java 11 on Linux. Our test cases can specify their requirements, and test distribution will make sure those tests are only sent to agents that can actually run them. And by the way, we're managing our agents with Kubernetes here, but an agent can be a VM, a container, even a physical machine. It's up to you. So now we'll kick off the build. We'll show the important parts of the build in real time, but we'll skip through most of the action here. First, we'll run the build without parallelism and without test distribution. This never runs more than one test at a time, and it takes just over a minute and a half. Next, we'll enable parallelism but not test distribution and try it again. Now we can run two tests at a time. That cuts our test time roughly in half, down to 46 seconds. Now let's turn on test distribution. When we run the build, it starts out running two tests at a time locally, then it runs more tests in parallel as remote agents become available. This cut our test time down to 26 seconds. Looking at the Kubernetes cluster that manages our agents, we have 5 agents already up and running. If we run the build again, agents continue to be spun up by the cluster so that at its peak, we're running 12 tests at once. That gets our test time down to 19 seconds, more than 4.5 times faster than our original time. Let's take a look at the Gradle Enterprise build scan for this build. This gives us a detailed look at all aspects of the build. From the Summary tab, we can see the overall statistics. As we noted, it took about 19 seconds. If we go to the Tests tab, we see a list of the test cases that ran, and we can drill down into any test case that looks interesting. All of the results from all of the agents are displayed here in one place, no matter how many agents were involved and no matter how many test tasks were run in parallel. Back on our machine, this example also generates the standard Gradle build report and the Jacoco code coverage report in the build directory. We can look at those to get different perspectives on the build. To sum up, our total test workload was distributed intelligently across multiple agents, and we got more than a 4x improvement without changing any code whatsoever. That's a fantastic result with our small example. With a more typical build that has hundreds or even thousands of test cases and dozens of agents, the performance gain could be even greater. Before we go, Gradle Enterprise has several technologies to make your builds as fast as possible. When you run a build and test cycle, the build cache makes sure you don't build anything you don't have to. Predictive test selection identifies irrelevant tests for local and PR builds, so you don't run any tests you don't have to. And test distribution makes sure that whatever tests you do run as fast as possible. All of those technologies optimize your builds. Finally, Gradle Enterprise's performance continuity is a methodology for keeping your builds as fast as possible as your code base grows and changes. The metrics and trends and analytics delivered by Gradle Enterprise give you all the insight you need to make that continuity possible. The bottom line, Gradle Enterprise makes your build and test cycles faster, keeping developers focused, productive, and happy.